Hello friends, welcome to our fourth video on learning computer vision. In this video we will essentially create a colorful image pixel by pixel by using numbers. So this is a very fundamental and powerful idea. By just inserting some numbers inside an array, we can create an image on the screen and we can create colorful images. So again, so far what we have done is we have taken black, white and yellow images and we looked inside what is the number inside the images, and now we are going to do the reverse. We are going to put some numbers inside an array and we will display those numbers on the computer as pixels, the reverse of what we have learned. If you can master this, you have mastered computer vision, and all the way to self-driving cars, to the future of computing, you can create powerful applications. So we will be using Python and OpenCV in this tutorial, and let's thank our sponsors. Visit Kimavi.com to learn computer vision and myguide.org to play with some amazing tools built using computer vision. Tools are free. So what are we going to learn in this video? We are going to make colorful images from numbers. So again, it's a powerful idea, and all we are going to do is write some numbers in code, and it can create our face, it can create a dog, it can create the Eiffel Tower, Taj Mahal, Statue of Liberty, or even the Golden Gate Bridge. Everything is numbers. By typing some numbers inside computer memory space, you can create the Golden Gate Bridge. Powerful idea. So I'll start with a very simple experiment. Here is a rectangle. It has three other rectangles, red, green, and blue. Think of it as one row and three columns. So one row and three columns and three different colors, right? So can we increase number of rows or columns, or can we create this on computer by just typing in some numbers? So can we create a row of three columns and color them red, green, and blue? So here is the first row, and let's write some code. All right, so there are a couple of ways to do it. One is we can write array inside a NumPy, and that can do it, or we can use a pillow library, which is a more simpler library. So why don't we use pillow, and we'll come back to writing an array in NumPy later. So what we are doing over here is we are importing pillow, which is a library, and we are importing the image function. We are doing a new image. It's an RGB image, and it has one column and three rows, right? So we are saying 1 by 3 column and rows, and we are putting some data inside the image. We are saying 255 for red, 255 for green, and 255 for blue, and finally we are saving this as rgb.png. So essentially we are using pillow as a library and putting some data, and finally we should see an image once we open rgb.png as image of one column, three rows. The first row would be red, the second row would be green, and third row would be blue. So we got it, right? So this is cool, but remember we were trying to create a one row and three columns. Instead we got one column and three rows. So again, it's important to understand column rows, rows columns, RGB VGR, depending on whether you are using pillow or OpenCV. In pillow you are in the RGB, red, green, blue color space. In OpenCV you are in BGR, blue, green, red color space. In pillow you are in width and height inside a rectangle, whereas in OpenCV, height and width, it's the opposite. Why it's opposite, don't ask me, that's how it is, right? Earth is spherical. Why is it spherical? I don't know. I do know, because of gravity. Okay, anyway, so here we have 3 rows and 1 column, but we want something different. So let's go ahead and change our code a little bit. We are essentially looking for 3 columns and 1 row, and we want our first column to be red, the second to be green, third to be blue, and that's why we got 25500, the RGB in the first column, 02550, the red is 0, the green is 255, the highest possible value, and blue is 0. So once we open this image, what are we going to see? We will see 3 columns and 1 row, 3 pixels. First pixel is red, second pixel is green, third pixel is blue. Again, this stuff is powerful. By using numbers, we are able to create pixels on an image. This whole video is nothing but pixels, which are images getting played at frames per second. So everything that you see on the screen is pixel manipulation, or rather number manipulation. Even my voice computer is storing as numbers and playing as numbers. Everything is numbers. If you love math, you love computers, and you love computer vision. If you don't love mathematics, maybe don't waste your time here. Do something else like gardening, or maybe grow strawberries, whatever. Anyway, so woohoo, looks like we got what we wanted. Beautiful. 1 row, 3 column. We can open this image inside Macintosh and see rgb.png. If you are a first time coder or a nth time coder, use Mac. It's easier to program than Windows, much easier. Anyway, so here we have, we created what we wanted. The dimension is 3 pixel by 1 pixel. So 3 columns and 1 row, right? So again, this is going 3 in width and 1 in height. So this is width and height. Our computers, like I'm recording this video on a 1920 by 1080p monitor. Like this video is on a 1920 by 1080. When I was recording the PowerPoint, I had a different resolution, like 1920 by 1200. And the Mac on which I'm working on, it has a 4K resolution, which is double of 1920 by 1080, right? So HD, Ultra HD, all this stuff, you can get it from Wikipedia. Everything in computers is essentially ratios, right? So the screens, so you can have a 1920 by 1080 screen, 1920 in width, 1080 in height, or so that's HD. You can also have what we call as a 4K, which is essentially triple or double of 1920, and you can keep going like this. Okay, so if we open RGB underscore V1 in our image editor, we see nothing because it's very tiny. Like on this screen, let me get my pointer going. I think it's Command L for laser pointer. Yeah, I got the laser pointer. So here you see this 3 pixel that we created. It's very tiny. You see it? If I say Command I, the laser pointer goes away. Good. So we see a pixel here, and we can expand it by zooming in, and now we see our 3 pixels that we just created. So this is all powerful stuff. Let's just recap what we learned. We learned that any image in the world can be written using numbers. Computers are made up of numbers. This include images, just 0 and 1. If images are nothing, we can find images in other images by finding sequence of numbers. There's some very powerful template ideas here. And by teaching computers what numbers mean and how to find numbers, we can do computer vision. So this is very, very powerful. Let's just recap. The single most important idea: we can find images in other images by just finding sequence of numbers. So the whole computer vision, Tesla's self-driving car, Apple unlocking your iPhone, or Amazon doing grocery checkout, you just walk in, walk out, is all computer vision. And this all stuff is happening by finding numbers in existing images. Can you believe that? The Tesla self-driving car is finding numbers on the road. What a crazy idea. Anyway, We can find images in other images by just finding sequence of numbers. We can teach computer what images mean by helping computers find numbers. So when Tesla is running a self-driving car, it's finding numbers on the road. Some numbers mean stop, some number means go. Wow, what an idea. So even we can find images and other images, like we can find the face of the soccer player or the soccer ball. What's going on over here? Let's just use our laser pointer. Command L will give me the laser pointer. Here is my laser pointer. So here you see the face. This guy has a face, this guy has a face, and here computer has found the face. Whatever you see over here, let's get rid of the laser pointer and let's get rid of the template. Command I to get rid of it. So this is what's going on behind the scene. Again, if you are liking this stuff, you love computer vision. If you like math, you love computer vision, and you can be on your way to amazing greatness. This is it, friends. All we are doing over here is we are finding numbers from Tesla's self-driving car to Apple unlocking your iPhone to whatever you can do with computer vision is nothing but take a image, find numbers, take a video feed, sequence of images, find numbers, run some algorithms to change numbers into simpler format. Like you can blur, you can use Gaussian blur, or you can use edge finding algorithms. But this is it. If you are not in love with computer vision, maybe this is not the right field for you. If you're getting more and more excited, we will do a lot more cool stuff with algorithms as you move forward. So again, get excited, get excited, get excited. Love math, love math, love math, love numbers, love algorithms. If you haven't heard of calculus, differential calculus, integral calculus, that's fine. If you have heard of Pythagorean theorem, and if you love math, you will love computer vision. So let's thank our sponsors, Kimavi.com. Visit it to learn computer vision and more, and myguide.org to play around with amazing tools built with computer vision. All right, friends, have a good day. Hope you like this video. That's it.